Before we start doing the dis method, I would like to explain why we use the formulas we do. And so the first formula will be the x-axis formula, which is when it's rotated about the x-axis. And this volume will be pi times the integral from a to b of the radius squared, so the r of x squared dx. And so breaking down these parts, you'll notice that these are parts of the area of a circle, pi r squared. And let me explain why. So this will be our shaded region, and we are rotating about the x-axis, and let's cut a little slice of it. So from this red dot, you notice in our cylinder, we can find the radius here. This top is a circle. So that's why we're using pi r squared. And yeah, so since that is our radius, this little thing up here, this will be considered r of x because we're rotating about the x-axis. So we are all in terms of x. When we're rotating about the y-axis, all of our terms will be in respect to y. So this will be our shaded region. We are rotating about the y-axis. And now our radius will be flipped over like this, and this will be our r of y. So the same reasoning, there's like a little disc over here. And yeah, that was not a very good drawing, but you get the idea. So now our formula will be v equals pi times the integral from c to d. And our c to d here will be, I'll highlight it in pink, r squared y, so r of y squared dy. And to exemplify the dx and dy, this is the height of our little cylinder. So that is our dy and that is our dx. So that is why we use these formulas, the v equals pi, integration from a to b, r squared x dx, and then the other one for y. Our first problem is to find the volume of a region bounded by y equals the square root of x equals 0, x equals 3, and revolved around the x-axis. And since we know it's rotated upon the x-axis, we know our formula will be the volume equals pi times the integration from a to b of our radius of x squared dx. And in this case, let's draw a graph first. We know that the square root of x, y equals the square root of x, the graph looks like that, and we are bounded by x equals 0. And let's say 1, 2, 3, this is x equals 3, and yeah, these are our bounds. And this is the area we are looking for. Our radius is going to be this, which is equal to y, and we know that our y equals the square root of x, stated here. So now that we know our r of x, and we know our bounds are 0 to 3, we can write down our equation. So the volume equals pi, bounded from 0 to 3, and then the square root of x squared dx. And we could simplify that further by writing down square root of x, well, squared is x dx. We know the antiderivative of x is x squared over 2. So our volume will equal x squared over 2 from 0 to 3. And now all we do is just plug in our bounds, and this will make it 9 over 2. Oh, and don't forget the pi, minus 0 over 2, which equals 9 over 2 pi, or 9 pi over 2. So that's our entire number 1. So problem 2 will be similar to problem 1, except this time we're rotating about the y-axis. So now we know that our formula for volume is going to be the volume equals pi times the integral from c to d of r of y squared, which is our radius, dy. And let's draw our graph. We know our y equals x squared is just a simple parabola, but we don't need both sides. So I'll just draw the right side. We're bounded by x equals 0 as well as x equals 2. So we know our c is 0 and our d is 2. And this will be our shaded region. This time, our r of y is from the y-axis and this curve, so it goes this way. And one good thing to remember is that r of y is equal to our x. In our previous problem, r of x was equal to our y. So now we just have to put this y equals x squared in terms of x equals, which is fairly simple. We just take the square root of both sides and we're left with x equals the square root of y. And our last step is just to plug in. So our volume equals pi times the integral from 0 to 2, and then our r of y squared, which in this case is the square root of y squared dy. And to further simplify, v equals pi from the integration of 0 to 2 y dy, and we know our antiderivative of y is simply y squared over 2. And then don't forget our pi again between the regions of 0 to 2. So now this is just a plug-in. So 4 over 2 minus 0 over 2 will simply just be 2, and bring over the constant, which is pi, and that's our final answer, 2 pi. Thank you guys for watching. I'm just trying to make videos every week about Calculus 2 stuff since I'm currently taking Calculus 2, and I'm using these videos to follow along in the future for my exams. So that playlist will be down below. Thank you.